Can you guys see my photo window here? It's a C drive, and go to program file and MIDAS GTS NX, and under here you can check under the manual folder you can check analysis reference and benchmark and verification and some tutorials under here, and also can find the user manual under the installation folder. And today's, as I told you, I will use a terrain function. Before that, under the sample folder, you can check the bedding plane sample here. Oh, and also I will use a bedding plane function today for the soil layer. And for the terrain function, I will use this DWG file with a different elevation, as you can see here. They are different, the elevation. And you can import this, something like control lines you can import to the GTS NX using the terrain function. So from my sharing folder, you can find this start file of GTS NX program. Okay, I will share this materials tomorrow. Okay, so when you open the starting file, you can see this scale box. Okay, this scale will be used for the ground solid, so I'm not using this scale now. So first go to bedding plane here. You can create yourself under here. Others. This is a plane name. You can define the name under here. You can modify. Okay. And today I will use import function, which I show you the sample. So when you open the sample, you can see this spreadsheet, and this is the borehole name, and this is the location, X, Y, Z coordinate system, each other. And this is depths regarding this boreholes. And you can change the name under here directly. Okay, so there are 5 numbers of boreholes which are using for today's session. Okay, so when you finish to fill out here, you can import using import function under this bedding plane widget. And you can see this spreadsheet. Okay, click open. Then you can see the imported data for the reference borehole. And this is the width, and I will use a 5 meters and click preview. Okay. When you increase this number, the width will be increased, as you can see here. Okay. So in this tutorial, I will use 5 meters for the distance. Okay. And click OK. So these faces will be used for the soil layer, the cutting the solid. And next, I will create the ground surface using this terrain geometry maker function. Okay, click this one. and terrain geometry maker, click this one. Then we'll go to another window for this terrain function. And I will import the DWG file, what I show you. And boarding, open. And I will move this one, the OR, and I don't need these two guys, so I will. Okay. So as you can see here, this cat file has imported to this terrain function. So click this window, then this one will be activating. Click this one, deactivate, click here, activating. Okay. So click this terrain geometry and select the base contour, everything here, under this window. And give me a moment, please. So if you have changed the elevation, then GTS NX, the terrain function will be detect automatically your desired height of the contour. Okay. So the values under this window, I will share you can find the values under my sharing PDF file. And corner 1 and 60, corner 2, 65 and 1. And I will use extraction 2.1 and Y also same. Okay, and ignore it. Okay, so as you can see here, the ground surface has imported. And after that, you need to export this surface. So I will give the name as ground surface. Base. Save. Okay, then I will close this one without any save. And after you import this, export this terrain TMS file, then you can import that file using this function, the import TMS file. Then you can directly see this file, what I created, and open. Then, as you can see here, the ground surface has imported to GTS NX program. Okay, so the next I will create the ground using this extrude function. Click and select the edges and change to selection method to edge, and this one. Okay, select it, and the direction is Z direction, and I will give 40 meter of length. Check with the preview. Okay, it's reasonable. Okay, so the next I will cut this solid based on those faces. So using this divide function, the divide solid, so select the solid first and select two surfaces. So select those four faces, preview. It will be divided. Okay. So after you divide the solid using the faces, when you change the selection method to solid, then you can select the solid by solid, which are divided by the faces, like this. Okay. So next, I don't need those curves anymore. These curves means border's location. Okay. And I will hide the curves. Okay. Okay. So the next, I will using this auto connect function to connect the solid for the meshing. And okay. Okay. So next, I will generate the mesh for the solid. Before that, I will delete the solid, what I don't need. Okay, and change the selection method to solid, and click this one, this solid, and delete. Okay, so this is the ground surface. So if I want to see the front and left and right and default. Okay, so select every solid, right click and generate a mesh, and I will give the size 3 meters for the mesh size. And property, I will keep this, the number 4, and go to advanced option, and I will use a higher order element for the FOS check. Okay, and okay, click OK. Okay, so mesh has generated. I will change the selection method to mesh set. There are 4 mesh sets for the ground. So if we want to see the properties from the selected mesh set, you can check under this properties window here. As you can see, the property is number 4 soil, maybe for every mesh set. So the next, I will assign the properties for each mesh set. So using the parameters function under here, the mesh tab element parameters, and go to 3D tab here, and selection method change to mesh set, and select the first layer, change the property, apply, and second also change, apply, and third layer, number 3. Okay, so after that, if you check the property window for the property, as you can see here, the property has updated, as I mentioned. Okay, so the next, I will create the boundary condition. Go to static slope analysis tab here and constraint. Go to auto tab and create the boundary condition. Just change the name. Okay. And next, I will create the self weight. Okay, click self weight here and just change the name self weight. Okay. And next, I will define the initial water level and raining. So the initial water level, I assume it starts from second layer. So I will hide the first layer of the mesh set. Right click, hide. And I will hide this boundary condition and self weight. I did just hide it, it's not remove. Okay, so go to top view, and in this tutorial I will use nodal head function for the water level. Okay, so the type keep node and values 0, and I will change the type to pressure and boundary set name initial. Okay, so I will select only this top part, so turn on this front selection only. And sometimes even I turn on this one, the front selection only, the below part also selected. So avoid this one. I will turn on the perspective view and select that. As you can see here, the front part has selected only. Okay, so you need to check the below part. Okay, so click OK. So just now I define the water level for the initial. Is the water level start from the second layer of the soil. Okay, so the next I will define the raining. So using this surface flux, click this one. So I will assume the raining starts from this ground surface. It is normal situation. And I will change the values at the unit system to day from second. Okay, then you can see the unit has changed. And values, I will assume it with 0.01 meter per day. And the boundary set name, raining. And I will select the type to 3D element face and select the faces. Please make sure that you need to select only top part. If you select under the inside the mesh, then the analysis will be got some error. Okay. So click OK. Then the raining has applied on the surface like this. And I will turn off everything. Okay. So today I did make the geometry with the terrain function, the terrain geometry maker function, and I will make the soil layer using this bedding plane. And I did generate the mesh, and I gave the boundary condition and self weight, and I defined the initial water level starting from the second layer here, and I defined the raining on the ground surface. Okay, so today's session is over, and tomorrow I will present to define the analysis stage and create the analysis case to perform the analysis. And then I will show you guys how to check the raining effect and factor of safety. And if you want to apply this raining, I recommend you guys to use the unsaturated property. Under the starting file, you can check these unsaturated properties. I used those values for the saturation. Okay, so I will conduct today's session continuously from the yesterday one. So under this model file, let me hide boundary condition. And yesterday I did generate the geometry for this slope ground using the terrain function here to create the ground surface using the control lines from CAD file, the DWG format. And I did make a soil layer using this bedding plane. And yesterday I did import from the sample spreadsheet. And after that, I generated mesh using the high order. And I gave the properties for each soil layers. And I gave the boundary condition and self weight. And I did create the initial water levels, which is starting from second layer of the soil. And I did create the raining condition on the ground surface. It's a 0.01 meter per day. So today, as I said, I will conduct to define the analysis stage and carry out the analysis and check the result. So let me open the define construction stage window. Go to steady and slow analysis tab here and click stage set. And you can create the construction stage, or you can directly open this window under here, right click, add construction set, and I will use stress page slope stage time. It's the same as basic course. Add. And when you double click this one, you can see the define construction stage window. So I think there are 4 stages. First one is initial stage for C-page analysis. And second is stress analysis to check the FOS with the initial condition. And the third stage is C-page analysis for the laning. And last stage is FOS check for the laning effect. So I will create the first stage, give the name, and change the stage type, steady state. And in this stage, I will activate every mesh set. And you can directly check your activated mesh set using this one, show data function, activate. Okay, let me deactivate. Activate, then you can directly see the activated mesh set using this one. And under this stage, I will activate boundary condition and initial water level. Okay, save. And go to next stage, click new. And I will give the name stress analysis initial FOS. And I need to change the stage time to stress analysis. And in this stage, I will activate the self-weight. And I will check this one, the slope stability analysis using the SRM. SRM is strength reduction method for checking the factor of safety. And save. And go to next stage. So in this stage, I will carry out the C-page analysis for training. So change, give the name. And in this stage, I will use the transient stage time and give the time. Okay, so I will activate the mesh set first. So in this stage, you need to deactivate the initial water level. It is okay because the initial water level will be stayed there. And raining. And next, I will click time step. Okay, you need to check the unit system here. You need to change to day. If it is second, you can change under here. Okay, so click again. And I will assume it is 2 days. And I will divide the steps, 24 steps, and check on save result and generate the steps. Then you can see the generated steps for 2 days divided by 24 steps. Okay. Okay. And save. And click new for next stage. Is a factor of safety for the raining. So raining FOS. So in this stage, you need to change the stage type to stress. Check on this slope stability here. Okay, and save. So just now I finished to define the analysis stage for the initial condition using the C-page analysis. And the second is FOS FOS check for the initial condition, and gave the raining using the time step 2 days. After that, the next stage is a factor of safety check for the raining step close. And you can see the stages what you created under here, the stage set. And also you can directly edit, just right click on here. Then you can directly see the define construction stage window. Okay, so as normal, I will create the analysis case to perform the analysis. Right click here, or under here, you can check the general here. It's the same window. Right click on here and add. So solution type, I will change to construction stage because I did create the construction stage, so I will use this construction stage for this analysis case. All right, and give the name of this analysis case, 3D raining 3D raining effect. Okay, and go to analysis control. And I will check on this initial stage for stress analysis. And just for your information, under this non-linear tab, you can change the error tolerance using this one, or then you can control the tolerance. Okay, but I recommend you to use a general error tolerance. Okay. Okay. You can see after that, you can see the created analysis case for this tutorial. And right click on here and click solve. Then it is performing the analysis. Okay, I will skip this stage, the performing the analysis, and let me open the Reject Pi, what I created. Okay. Okay, so I found the result file. All right. I'm not sure whether you guys know about this. You can directly open the exe file, just drag and drop here. Okay, so after performing the analysis, then result tab will be open. So you can check the results from each stages. So this one is initial condition with a C-page analysis, and this is a FOS check for the initial condition, and this is a SRM result, the SRM analysis result. And this one is raining stage. It's 2 days divided by 24 steps, and you can check every steps like this. And this is a FOS stage for the raining, and this is a SRM result for the raining stage. Okay, so as you can see here, you can check the factor of safety directly under here, and the initial condition is around 2, and raining stage is around 1.03. It has reduced. I think it is a Lie number. Okay, so under from this result, let me check the water level increasement graphically. So double click this one, then you can see another C-page result and others, and I will use this one, and pore pressure head. Then you can directly see the pore pressure head values, and you can move to other stage just using the stage bar here. Okay. And if we want to see the exact shape of increasement water, then you can use this ISO value surface function here. Click this one, and you can see this window, and I will set the middle value to 0. And I will lock the values, this value, the 0. Then after this, then if you move to other stage, you can see the water has increased stage by stage. Right. Okay, so next result is checking the shape of failure surface using this one, max shear, and I need to turn off this one. Okay, so this is a failure shape for from the initial condition, and after the raining, max shear here is here. Right, so if you want to see some displacement, go to stress analysis for initial condition and double click this displacement and total displacement here. Okay, and I'd like to say the displacement under this SRM analysis is just for reference of failure. You don't need to use this value from the SRM analysis. Just check the failure point, something like that. All right, so just now I finish to present about session number 2 for